Welcome to the course Calculus 2. This is the first week lecture, the first lecture of the week 1 of the course. In this lecture, we introduce the space Rn, n-dimensional space Rn. Okay. We are familiar with the set of all real numbers, which are usually denoted by the symbol R, and also we are familiar with the algebraic operation addition, multiplication defined on it. Similarly, subtraction and division defined on set of all real numbers. Every real number is represented by a unique point on the number line. Also, every point on the number line represents a real number, and it is called real number line. So, it is known as a one-dimensional space. Now, we move to the two-dimensional space. The two-dimensional space R2 is defined as a collection of pair of real numbers x comma y. Here the x and y are real numbers. Thus, R2 consists of all ordered pair of real numbers. The ordered pair x comma y means that the first coordinate is x and the second coordinate is y. For example, you take the pair 3 comma 5 and the first coordinate is 3, second coordinate is 5, which is not same as 5 comma 3, which is a different point. So, if you change the order, it will become different point or different point in the plane it will denote. So, the points x comma y and y comma x are different unless x equal to y. Okay. Next, we move to the three-dimensional space. Similarly, the three-dimensional space is defined as R3. It is denoted by R3 and it is defined as a collection of all triplets of real numbers x comma y comma z. Thus, R3 consists of all three tuples or triplets of real numbers. Here also the first coordinate is x, the second coordinate is y, and the third coordinate is z. So, next we generalize this idea to get an n-dimensional space. The number n can be a natural number, n equal to 1, 2, 3, 4 and so on. So, this n is a natural number. The n-dimensional space Rn is defined as a collection of n tuplets of real numbers. Thus, Rn consists of all order n tuples of real numbers x1, x2, xn, where these xi's are real numbers. Here the first coordinate is x1, the second coordinate is x2 and the nth coordinate is xn. This Rn is basically the product of R to itself n times, that is R cross R n times. If the dimension n is greater than 1 in this Rn, the elements of Rn are called vectors. It is either denoted by capital letters or uppercase letters or boldface letters in the books. While writing on the paper, we prefer to use capital letters for vectors. In school level, you might have used the arrow symbol to denote the vectors, that is putting arrow symbol above the letter. So, that is used for the denoting the vectors. Okay. Here we may not use that arrow symbol. Whenever it represents n tuplets, it is basically representing a vector in Rn. If the dimension n is 1, the elements of R are called the scalars or just the real numbers, and the scalars, the real numbers are generally denoted by small letters or lower case letters. Okay. So, as I said, the geometrically R is represented by a number line. Similarly, R2 can be represented by a plane. Select a point to be the origin of the coordinate system and choose two mutually perpendicular straight lines at O to be x and y in the plane. Any point P in the plane can be assigned coordinates in the rectangular or Cartesian coordinate system as x comma y. So, next, the earlier we represented by a Cartesian coordinate system. Now, we can represent the points in R2 by another system which is called polar coordinates. Here you fix the origin, okay. Here we fix the origin here as O, or here it is fixed as a O. This is 0 comma 0 in the coordinate system. Choose two mutually perpendicular things x and y with the P is a x comma is a Cartesian coordinate system. Okay. Now, this P can be joined by a ray is this OP. Okay. So, it is called a position vector. The number R, which is basically the directed distance from O to P, is called R, okay, which is the magnitude of the vector. Okay. The second number theta is the directed angle from this positive real axis or this polar axis or initial ray to this. Okay. So, this is angle or amplitude. Okay. So, this r comma theta is called polar coordinates of the point P. Okay. So, for each non-zero point P x comma y, which is not equal to 0 0 origin, the polar coordinates r comma theta can be defined. Okay. And the relation between these Cartesian coordinates and the polar coordinates are x equal to r cos theta and y equal to r sin theta, okay, where r square equal to x square plus y square and tan theta equal to y by x. Okay. So, this is the relation between the Cartesian coordinate and the polar coordinates of the point in R2. The important point to note that whenever the angle is theta, so you can see that theta plus 2 pi also another angle, okay, so representing the same thing. So, theta plus 2 pi, theta plus 4 pi, theta plus 2 n pi also denote the same point. Okay. So, this theta is not a unique number, that any integer multiple of 2 pi added also represent the same angle. Okay. Now, we have done for R2. Similarly, we look for the things. Before going to that, when P is origin, okay, what is happening? Okay, then R becomes 0, theta is undetermined. Okay. These polar coordinates are defined only for non-zero points. For the origin, the polar the coordinates are not defined because the theta we cannot define it. Okay. So, then we move to the three-dimensional space. In Cartesian coordinate or rectangular coordinates, how to represent it, or geometrically how to visualize it. Select the point O as the origin 0 comma 0 0 and choose three mutually perpendicular straight lines at O to be x, y and z coordinate axis. The y and z axis are on the paper and the x axis is perpendicular to this plane and points towards the reader or viewer. In this orientation, x comma y and z from what is called right handed coordinate system. So, any point x comma y system, this is the x axis, this is the y axis, z axis. Okay. So, y z axis are basically on the paper, x axis is perpendicular to y z plane, which is basically pointing towards the viewer. So, this system of coordinate is called Cartesian coordinate system. The points in R3 can be represented by another system of coordinates, which is called cylindrical coordinates. A cylindrical coordinate system consists of polar coordinates in a plane together with the third coordinate z measured along with an axis perpendicular to r theta plane. Okay. So, basically the cylindrical coordinated system is basically, so in x, y is basically a polar coordinates r comma theta and z is kept as same. Okay, that is the cylindrical coordinate system. Then the relation between cylindrical and rectangular coordinates are given by x equal to r cos theta, y equal to r sin theta and z equal to z. Here the little r is equal to x square plus y square and tan theta equal to y by x. These cylindrical coordinates are convenient when there is an axis of symmetry in the object. Next we will see the points in R3 can be represented by another set of coordinate system which is called as a spherical coordinate system. These spherical coordinates are useful when there is a center of symmetry that we can take the origin. Spherical coordinates basically rho, phi, theta of a given point are shown in this figure. Basically rho is the distance between origin and that point P. Okay. So, the rho is equal to square root of x square plus y square plus z square. Okay. That is the distance from origin to the point P. And the rho basically measured from, it is called latitude angle. It is measured down from the z axis to the line OA. So, this phi is measured from z axis to downwards to that OP vector. Okay. So, that is phi. And the third coordinate which is called longitude angle, which is theta, which is same as the polar coordinates angle theta. Okay. So, that is the one basically this is the one theta, this is phi. Okay. The spherical coordinates are basically rho, phi and theta. Okay. So, the point P is this one and this phi is the angle measured from the z axis downwards to the position vector OP. Okay. Theta is the angle which is polar angle. Since this angle is phi, this angle also become phi, that gives z equal to rho cos phi and r equal to rho sin phi. Okay. Now, we will elaborate these three coordinates, spherical coordinate. The radial coordinate is the first spherical coordinate which is rho, which is the distance from the origin to the point P. Okay. Rho is always non-negative and is 0 only if P coincide with the origin. The second spherical coordinate is latitude angle phi, which is measured down from the z axis to the line OP, that is the angle from the positive z axis to the line OP. So, it is restricted to the interval 0 less than or equal to phi less than or equal to pi. Now, the third spherical coordinate, the longitude angle theta, which is same as in polar or cylindrical coordinates. It is the angle between the positive x axis and the projection OQ of the position vector OP into the xy plane. Usually, we restrict theta to 0 to 2 pi. Some books, the spherical coordinates, they write it in different order. Instead of rho phi theta, they will write it as rho theta phi, that is theta and phi they write it in the reverse order. So, you should watch out for this when you read elsewhere. In R3, the points are, we have given three coordinate system representing in three coordinate system. One is Cartesian coordinate system, second one is a cylindrical coordinate system, third one is spherical coordinate system. Now, we will see what is the relation between one coordinate system to another coordinate system, or how to convert a point given in a one system to another coordinate system. For example, the relation between the spherical coordinates and the cylindrical coordinates are given by r equal to rho sin phi and z equal to rho cos phi, theta equal to theta. Okay. So, spherical coordinates are rho phi theta and cylindrical coordinates are r theta z. So, this is a cylindrical coordinate. Spherical coordinates are rho phi and theta. Okay. So, the relation between cylindrical and spherical coordinate is given by little r equal to rho sin phi, z equal to rho cos phi and theta equal to theta. Next, we will see the relation between spherical coordinates and Cartesian coordinates. Okay, Cartesian coordinates is x, y, z and spherical coordinates rho, phi and theta. Okay. The relation is x equal to rho sin phi cos phi, y equal to rho sin phi sin theta, z equal to rho cos phi. Okay. The relation is x equal to rho sin phi cos theta, y equal to rho sin phi sin theta and z equal to rho cos phi. So, we now end this video with this information and will meet you in the next video. Thank you.